Hello everyone, my name is Pradyumn Mahajan. I am a first year undergraduate student of the Department of Aerospace Engineering, IIT Kharagpur. My roll number is 21AE30017 and I am from section 20. For my second DIY assignment, I have made a smart study table using Tinkercad. To do this, I have used an Arduino Uno board, an ultrasonic distance sensor, a temperature sensor, a photoresistor, a red LED, an L293D motor driver IC, a DC motor which is connected to a table fan, a 9-volt battery, and 2 resistors. This device first measures the distance of a person from the table using the ultrasonic distance sensor. If this measured distance is less than a particular threshold value, then the temperature sensor measures the room temperature and accordingly rotates the table fan connected to the DC motor with the required speed. The speed control of the DC motor is done through the L293D motor driver IC, which is powered by a 9-volt battery. The photoresistor measures the light intensity of the room and accordingly controls the brightness of the table lamp, here represented using an LED. Now let's take a look at the code. The dist variable stores the value of distance read by the ultrasonic distance sensor connected to pin 13 in centimeters. If this distance is less than the value stored in the max dist variable, then the temperature variable stores the room temperature read by the temperature sensor connected to analog pin A0. If this value is less than 27, then pin 5, which is connected to the enable pin of the motor driver, is set to 0, and pins 3 and 4, which are connected to the input pins of the motor driver, are set to low. This means that the motor is off. For a temperature range of 27 to 35 degrees Celsius, the pin 5 is now set to a value of 85 and pin 4 is set to high. This means that the motor is now on and is rotating with a certain speed. For a range of 35 to 45 degrees Celsius, the pin 5 value is increased to 170, which means that the rotation speed of the motor has now been increased. And for temperatures greater than equal to 45, the value of pin 5 is set to 255 and the motor is now rotating with maximum speed. The light intensity variable stores the value read by the photoresistor connected to analog pin A1 after mapping it to a range of 0 to 255. If this value is greater than 160, then pin 9, which is connected to the LED, is set to low. As the value decreases from 160 to 75, the brightness of the LED increases linearly from 0 to 255. And for values less than 75, the LED glows with maximum brightness. Now, if the dist value is greater than max dist, then both the motor and the LED are turned off. Now, let's start the simulation. Now, as we can see, when the person is out of range of the ultrasonic sensor, then both the LED and the motor are turned off. When he comes in range and the temperature sensor has a value of 25 degrees Celsius, then the motor is off. As the value increases above 27 degrees Celsius, the motor starts rotating with a speed of around 5000 RPM. As this value increases above 35 degrees Celsius, the speed becomes around 10,000 RPMs. And as it increases above 45 degrees Celsius, it starts rotating with a speed of 16,000 RPMs. When the room is dully lit, then the LED grows with maximum brightness. Now, as the room light intensity increases, the brightness of the LED gradually decreases, and eventually the LED turns off. Now, we will copy the text code into the Arduino IDE. I have now copied the text code from Tinkercad into the Arduino IDE. Now, on verifying this code, it has compiled successfully, which means that there are no errors in the code. And this code can now be uploaded into an Arduino. Thank you.